be looking at linear transformations. When we think of lines, the parent function, or like the most general equation for this function, is f of x equals x. Now we all know that is the exact same thing as y equals x, meaning our slope is 1 and the y-intercept is 0. Whenever we are talking about transforming a line, it's just the movement of that line. And then it's going to affect, the transformation will affect the values of m, so it'll affect the slope, and the values of b. So what we're going to look at today is a couple examples. We're going to jump right in. If we are looking at the graph f of x equals x, that is, like we just said, that is the same thing as saying y equals x. So that means that for this one, our slope is 1 and our y-intercept is 0. So if I'm looking at this first one, I would start here at 0, and I would count up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Remember, if you want to go the other way, you can. You just have to make sure that it's both a negative direction. So negative, negative makes a positive. Negative, negative makes a positive. Negative, negative makes a positive. Now we're back to our just straight up lines, so we don't have to worry about is it dotted, is it dashed, is it solid. So I'm going to use my handy dandy greeting card I've been using, and I'm going to draw that line. So there's the f of x, and I will just label that f of x so that I know I'm talking about this one. Now I'm going to look at g of x. G of x equals 2x plus 5. G of x equals 2x plus 5. So that means my slope is 2 and my y-intercept is 5. So I will go to 5 on my y-axis. I put a point. My slope is 2, so I count up 2, to the right 1, or I could count down 2 to the left 1. I'm struggle with lines. So I'm going to draw that. Okay, so they are now graphed out. A says, what changes from the parent function to g of x do you see? Well, when I look at the parent function, the changes that I see is I see that the slope is 1 here, the y-intercept is 0, the slope is 2 there, the y-intercept is 5. So I would say looks as though the slope and the y-intercept change. And then to kind of expand on that, meaning both lines are positive sloped, comma, but I'll go ahead and name this g of x. But g of x has shifted up 5 units, because when I look at this original and then I look at this one, it has shifted up 5 and has gotten steeper. So this was our original line here, f of x. And then in the equation, in the actual function, it is telling me that my slope changes, that my y-intercept changes. When I graph it out and I compare them, I notice that from my original, which is f, to g, I had to shift up 5, and then the line rotated to get steeper. So you notice it started here, and it shifted, and then it also got steeper. Second example. Graph f of x equals x and g of x equals negative 1/3 x minus 3. So let's start with f of x. Slope is 1, y-intercept is 0. Y-intercept is 0, slope is 1. Again, count up and to the right or down and to the left. Up 1 over 1, up 1 over 1. Draw that line. So that's my original f of x. And we keep saying parent function because f of x equals x or y equals x is the parent function. For g of x, my slope appears to be negative 1/3. My y-intercept is negative 3. So now, instead of being at 0, it looks like it's sliding down to negative 3. And then my slope is negative 1, meaning I would count down 1, to the right 3, down 1, to the right 3. Or if I need to go the other way, exact opposite direction, up and to the left. Okay. Oops. All right. So now this one, it looks like we have a lot to talk about. So when compared to the parent function, what changes have been made to the equation? In the equation specifically, slope changes from 1 to negative 1/3. Y-intercept changes from 0 to negative 3. That's what I see in the equation. What do you notice when you graph the two lines? So when we graphed them, I notice that g of x has shifted down, right? We can see that. And then it has totally rotated because the slope is now negative. So instead of increasing, the line is now decreasing. So g of x has shifted down and has rotated to become a negative sloped line. Oops. Help me with my spelling. G of x is shifted down and has rotated to become a negative slope line. So f of x is that parent function. It's going through the origin. When we looked at the next equation, it was negative 3. That means we had to go down 3 spots, 3 units. And then our slope also changes. So that's that rotation to make it a negative slope line. Number 3, parent function again, y equals x. We should be pretty good at graphing this now. We graphed it a few times. The other equation is y equals negative 2x minus 2. Now this one, using our prior knowledge on perpendicular and parallel lines, if we say that this is y equals x, I have to actually write it out because I don't have the function name, and then this other one is y equals negative x minus 2. What do we notice about these two lines? Well, this one has a slope of 1. This one has a slope of negative 1. So if I'm thinking opposite reciprocal, I'm thinking perpendicular lines. When compared to the parent function, what changes have been made to the equation? The slope changes to negative 1. The y-intercept changes to negative 2. What do you notice when you graph out the two lines? So here's where we can talk about that perpendicular. The fact that y equals x has a slope of 1 and y equals negative x minus 2 has a slope of negative 2 creates the situation where, what do we notice? Well, we notice that the lines are perpendicular. So that's all you could say on that one. You can go into that it shifted down to, that's perfectly fine. But in my mind, the most important thing to see from this graph is that they are perpendicular lines. Okay, we have our last question. We're going to be done with our notes. This one is a word problem, so I just kind of wanted you guys to see what it would look like if you created, or if you had a word problem with this topic of transforming the lines. So word problem here, members of a health club, think gym, pay a one-time membership fee plus a monthly charge. Recently, prices have increased. The new membership cost is represented by g of x on the graph below. So right here, that's what's representing the new membership. The old membership cost is represented by f of x equals 25x plus 100, where x is the number of months. So, number 1 says graph f of x on the coordinate plane to the left. So 25x plus 100. Well, I know this is my y-intercept because it's the constant, it's by itself. So since that's my y-intercept, I will go to 100 on the graph. And then when I first look at this graph, I notice the scaling is different. So it looks like it goes up by 50. So 50, 100, 150, 200, 250, 300. So if I'm starting at 100, 50, 100, I'm actually starting at that second notch on the y-axis. And then again, you got to pay attention to the scaling. So if my slope is 25, I could either, if I'm going up to the next line, then I am going up 50. So if my slope is originally 25, we're thinking 25 over 1. However, I'm going up by 50. So if I wanted to change 25 over 1 to our scaling, which seems like it's doubled, that means 25 times 2 is 50. 1 times 2 is 2. So that means now I'm going up 50 over 2. Up 50 over 2. Up 50 over 2. I'm just going to continue it out. Connect my points. Okay, so we graphed it. Good. Describe the transformation that has taken place. So how have the graphs changed from f of x to g of x? And this was f of x. And really, if you want to think about it the other way around, probably should say g of x to f of x, in all honesty, because g of x was that original equation. So how do they change? Well, all I noticed, to me they look parallel, because it looks like you go up 1 over 2 notches, up 1 over 2, okay? So they're parallel lines, which means they both have the same slope. And if they both have the same slope, that means that the monthly cost is the same, right? And then the only other thing that I notice is that the y-intercepts differ. So if you look at this, the new membership, oh, that I get it now of why they say, so yeah, we could leave it like this, f of x to g of x. Sorry to confuse you. I forgot that f of x is the original and g of x is the new. My fault. So yeah, leave it as f of x to g of x, but let's go back again. The new membership cost is represented by g of x, and then f of x represents the old one. So this line down here is that old membership. So even though these people are paying the same each month, it does look like the original cost increases. So the line shifts up 150 units or 3 spaces because of the scaling. Okay, so let me go through that one more time because I'm sure I threw in some confusion here with this part. Graph the lines. So we did that there. Graph the lines. Describe the transformation that has taken place. The slope stays the same, but the line has shifted up to have a new starting point. That's how it got expensive, more expensive each month. And then so we know that they are parallel because they have that same slope. And we know kind of from here in the word problem, but also looking at the graph, if you're looking at that original membership cost, f of x, looking at the new one, it does increase, which means if it's increasing and they have the same slope, then that y-intercept must be the thing that increased, which is correct, and went from 100 to 250. So that's why we said 150 units that it shifts up, but really it's only 3 spaces.